Hi everyone, and welcome to our video on using the unit circle on a graph to find terminal points. So these are kind of rare. The majority of the time we're using the unit circle, like the quoted unit circle here, to help us find terminal points, or we're making the little sketches like we did on these last couple videos. Here they give us the unit circle on a graph, and we need to figure out terminal points based on it from there. So it says graph is the unit circle, so that means these are, let's mark these. So that's 1, 0. Here's 0, 1. So I'm keeping it small. Here's negative 1, 0 as a point. And then there's 0, negative 1 as a point. So I'm just marking saying that's the unit circle. Those are the 4 easiest points to find. And it says the mark in the first quadrant of the unit circle represents t equals 1. All right, so let's show that in green. So they're saying from our initial point to there is t equals 1. So let's mark it right there. I'm going to erase that in a second anyway. Okay, so that length is t equals 1. And then it says following the marks on the unit circle are 1 radian apart. So that means this to there is another 1, which means from the initial point all the way to where that one ends would be t equals 2. Okay, so, but this is getting a little messy. Let's just mark it right here, t equals 2, and then I'm going to erase that in the green. So sorry if you were copying it exactly. It's not a big deal if you did copy it, but I'm just cleaning it up. And then it would continue with the pattern. So here's t equals 3. Here's t equals 4. Here's t equals 5. Here's t equals 6. And then t equals 7 is not on here. So afterwards, the 7, 8, 9 are no longer shown. Okay, so it only goes to these. All right, and then it says use the unit circle that's graphed to approximate the terminal point given by the real number t. So on number 1, they say for t equals 1. Okay, so that means we need to find this terminal point based on that t equals 1. All right, so t equals 1. It looks like it's in between. Let's figure out the scale. So it's got 1, 2, 3, 4, 5 grid marks. So as fractions, that would be 1/5, 2/5, 3/5, 4/5, and then 5/5 to get to 1. However, these can be changed to decimals pretty quickly. The 1/5 is the same as 0.2. 2/5 is 0.4. 3/5 is 0.6. 4/5 is 0.8. Okay, so I'm going to use those decimals instead, and the y scale is the same. Okay, so that looks like it's right in between 0.4 and 0.6, so that means it's 0.5. Okay, so 0.5. And then the y, let's go ahead and mark, there's the 0.2, 0.4, 0.6, 0.8. It's above 0.8, and it looks like it's maybe a 0.9. Okay, so we'll just estimate it. Okay, so our y coordinate and x coordinate are known. It looks like our terminal point for this is 0.5 and 0.9. Okay, that's that. All right, now let's find t equals 5.5. All right, so for t equals 5.5, so we have t equals 5 and t equals 6. 5.5 then is probably right in between those two, about there. That looks like it's equidistant from 5 and 6. So here's t equals, let me mark it in green also. Here's t equals 5.5. And that means our terminal point, again, using this grid, it looks like it's probably 0.7 for our x coordinate. Okay, so that's in between 0.6 and 0.8, and then down 0.246, that also looks like it's maybe 0.7 also, but except it's down, so that means it should be a negative. Okay, so it looks like it's about 0.7 and negative 0.7. Okay, and these are just estimates, so as long as we're near those values, we're correct. It doesn't have to be exactly spot on. Okay, so chances are it's not exactly 0.7 and negative 0.7, but those are going to be close enough. And then let's get the last one here. So t equals negative 3.7. Okay, so first, I'm going to do the positive 3.7. Okay, so positive 3.7 would put us maybe about there. Okay, so here if this is t equals 3 and this is t equals 4, 3.7 is closer to t equals 4 than it is to 3, so it's probably about there. And then, well, that would have been, okay, so it's going to get messy again. That would have been the positive. So I'm going to erase this in just a second. So this length right there is the positive 3.7. Okay, so that means, well, I guess we can keep it because it's the last problem anyway. That means the negative would have gone the same length around, but clockwise. So this in the red to there. Okay, so notice that in the red and that in the green are the same lengths. One went counterclockwise and one went clockwise. So this is where I'm saying that t equals negative 3.7 is. So there's t equals, let's actually do it in red. T equals negative 3.7 is about there. And then it looks like the terminal point. Okay, so we're going left, so that means it's a negative x-coordinate, 0.2, 0.4, 0.6, 0.8. So it looks like that's negative 0.8. And then up 0.2, 0.4, 0.6, 0.6 went up. Okay, so I think it's negative 0.8 and 0.6. Okay, there we are. Okay, so that's how these ones work. Notice, okay, so and the reason that so these are rare, they don't usually do that. Usually we're sticking to our unit circle where we have our t values. So I'm just going to mark the quick ones that are on the axes. Okay, so there's, and that's 2 pi. Okay, so those are our main t values on our unit circle. However, pi is still like 3.14. Okay, so this is about 3.14. So it's just saying you can use values that aren't pi or parts of pi to still figure out where you are on the unit circle. So notice where t equals 3 was. T equals 3 was just short of where pi was. Okay, so 3.14, that's a little short of 3. Yeah, that's where 3 is. Okay, so that is just showing, again, those pi's are part of the unit circle because circles depend on pi because of their circumference formula. But they don't have to involve pi. They can involve decimals or negative numbers or whatever. Okay, so anyway, so that's just showing where they would be if we did have them. Again, the main thing to end this video, the main thing is know this unit circle. Those are the main ones. So like 1, 2, and 3 right here. Stuff involving pi. One more time, just a quick scroll. So these ones we're about to see with trig involve pi. Okay, so more pi, more pi, more pi. Stuff involving pi. Okay, so there they all are. Okay, tables of pi. Okay, so make sure you know that unit circle really well. If you know it well, this class becomes a lot easier. If you don't know it well, the class becomes very hard. Okay, so make sure you know this the best you can. Okay, other than that, thanks for watching, and I'll see you again next time.